Finding the missing link. In 1894, Eugène Dubois named fossils discovered in Trinil, Java, Pithecanthropus erectus, meaning upright ape man. He noted that while the skull cap was low and possessed primitive features, the femur was remarkably similar to that of modern humans. Based on this, he argued that humanity achieved bipedalism before the brain fully developed, a revolutionary proposal that overturned the academic consensus of the time. Taxonomic unification. Later, Sinanthropus pekinensis was discovered at Zhoukoudian, China. Although they had a larger average brain capacity than Java man, Weidenreich revealed that their anatomical features were fundamentally similar to the Java fossils. By the 1950s, these regional variations were unified under a single species, Homo erectus. However, recently, the relationship between the early African fossils and the Asian forms has emerged as a new point of contention. The Dmanisi site in Georgia, dating back approximately 1.85 to 1.78 million years, represents the oldest confirmed Homo erectus site outside of Africa. Stratigraphic evidence here shows that Homo erectus spread to Eurasia almost immediately after, or perhaps even before, fully evolving in Africa. This suggests that a large brain or advanced Acheulean tools were not prerequisites for the exodus from Africa. The 5 skulls found at Dmanisi, particularly the perfectly preserved Skull 5, shocked the scientific community with its small brain combined with a massive face. While some scholars argued that the morphological differences between the Dmanisi fossils warranted classification as separate species, Lord Kipanidze and Zollicoffer countered that this variation does not exceed that found within modern human or chimpanzee populations. This strongly supports the possibility that early Homo species are not distinct species, but variations within a single evolving lineage. Homo erectus. Body proportions and thermoregulation. The Nariokotomi boy, discovered in Kenya and dating back 1.5 to 1.6 million years, best illustrates the physical characteristics of Homo erectus. He possessed long legs, a narrow pelvis, and a barrel-shaped chest. It is estimated that had he reached adulthood, he would have stood 185 centimeters tall and weighed 68 kilograms. This body shape is interpreted as an evolutionary adaptation for effective heat dissipation in a tropical savanna climate. Bramble and Lieberman argue that Homo erectus underwent specific evolutionary changes, not just for walking, but for endurance running. Anatomical features such as the nuchal ligament that stabilizes the head, the shock-absorbing plantar arch, the gluteus maximus, which balances the trunk during running, and long Achilles tendons are traits evolved exclusively for running efficiency. This ability likely enabled persistence hunting, chasing prey in the midday heat until exhaustion, or rapid scavenging to secure protein-rich food sources. Growth in the brain dental microstructure analysis revealed that while the Nariokotomi boy had the physical stature of a 15-year-old at death, his actual age was only between 8 and 11. This implies Homo erectus had a rapid growth rate, similar to great apes. Furthermore, to resolve the contradiction between a narrow birth canal and an increased brain capacity, secondary altriciality emerged, where the brain is born immature and grows rapidly after birth. However, the narrow thoracic spinal canal suggests a lack of breath control, implying they could not speak complex, fluent languages like modern humans. In the past, the Mobius line hypothesis dominated, claiming that Acheulean hand axes did not exist in East Asia. However, the discovery of hand axes in Yongchuan, Korea, and large cutting tools in the Bose Basin, China, refuted this. Confirmed by tektite dating, these stone tools prove that Homo erectus in East Asia possessed the ability to manufacture sophisticated tools in response to environmental factors. The Gesher Benot Yaakov site in Israel, dating back approximately 790,000 years, provides the most definitive evidence that Homo erectus controlled fire. Evidence: burned flint micro-artifacts, plant seeds, and wood were found in specific clusters rather than scattered randomly. This implies the use of artificial hearths rather than natural wildfires, suggesting that cooking, heating, and defense were established behaviors by the early Middle Pleistocene. A freshwater mussel shell fossil found in Trinil, Java, dating back 500,000 years, has forced a re-evaluation of Homo erectus's cognitive abilities. They use shark teeth to drill into shells to cut the mussel for consumption and sharpen the shells to use as tools. Even more surprisingly, a geometric zigzag pattern engraved by a shark tooth was discovered on a shell surface. This serves as decisive evidence of purely aesthetic or symbolic behavior, demonstrating their capacity for abstract thought. Synthesizing the literature, it is reasonable to view Homo erectus as a single species that originated in Africa and rapidly spread to Eurasia around 1.85 million years ago. They expanded their ecological niche through modern body proportions and endurance running capabilities. Despite limitations in brain capacity, they possessed high cognitive flexibility, evidenced by fire control, sophisticated tool making, and early forms of symbolic behavior. Therefore, Homo erectus should be defined not merely as a transitional being, but as the first global human who pioneered new environments through technology and culture.